For today's lesson, our focus standard comes from Grade 7, Expressions and Equations, Standard 4. Use variables to represent quantities to construct and solve equations. Our topic comes from our unit on simplifying expressions and equations, solving equations with grouping symbols. Our essential question is, if an equation has parentheses, do you have to use the distributive property to simplify it before solving it? Please take a moment, pausing the video if you need to copy down the topic and essential question into your header, along with today's date, set up your question column and your note column, and resume the video when you're ready to begin. So let's talk about what we mean by grouping symbols. The most common grouping symbols are parentheses, brackets, and fraction bars. I think we're pretty familiar with parentheses and brackets. We are also familiar with fraction bars, but it would look like this, a horizontal bar, and it would have a set of problems to do in the numerator as well in the denominator. So rather than just having one value up here in the numerator or denominator, it might actually have a set of operations for us to do. And in order of operations, in a fraction bar, parentheses or brackets, you have to simplify that first before continuing your calculation. So what we want to talk about today is how do we treat these when we see them in equations with a variable that we're trying to solve for. So let's look at our first example. We have the equation 3 times the quantity x plus 4 is equal to 15. Now, using what we learned in simplifying expressions, many of us might be tempted to take this 3 and start distributing it, multiplying it by each term inside of the parentheses. That is excellent if you're trying to simplify and combine like terms, but my question is, going back to that original the question in our essential question, is, do I have to use that distributive property first in this equation, or is there another step I can do to solve it? Let's think about that. Remember, what is the operation that's hiding right here? This 3. Well, I already alluded to that because we talked about taking this 3 and multiplying it by each term inside of here. So we know that the term that's hiding right here between the 3 and the grouping symbol of these parentheses is multiplication. Further analyzing this equation, there's nothing else in this expression. It's just 3 and this grouping symbol of x plus 4. So we can actually get rid of this 3 without having to multiply it through and use the distributive property. So let's go ahead and get set up. First, we're going to use the vertical line at the equal sign to divide the left side of the equation from the right side of the equation. And we said that the operation right here is multiplication. What is the opposite of multiplying by 3? That's right, it'd be dividing by 3. So we can actually start by taking this left expression and dividing by 3, and do the same thing on the right to keep our equation balanced. Let's go ahead and do that and see what we would have remaining. Let's see, do we agree? When we divide both sides by 3, we are saying that this whole group is being multiplied by 3. So if we divide by 3, 3 divided by 3 is 1, and it leaves us with the group x plus 4. And again, we can do this because x plus 4 was grouped together. So we're getting rid of what was outside of this parentheses, further away from the x, the variable. Since we divide by 3 on the left, we also have to divide by 3 on the right, and 15 divided by 3 is 5. So what's the next step? We now have x plus 4 is equal to 5. How do we isolate this x and get it by itself? We do the opposite operation as what's happening here. So go ahead and complete this problem, and let's see if we agree. When I subtracted 4 from both sides, I got that x was equal to 1. Do you agree? Well, if we substitute 1 in for x up here, 1 plus 4 is 5, and 5 times 3 is 15. So that works. Let's try our next example. Here we have the sentence, the difference of r and 16 divided by 5 is 6. So here we have to do a little translating. What is that going to look like? Go ahead and pause the video here and think about that. Resume the video and let's see if we agree. Alright, so here's how I translated it. It's the difference of r and 16, and we've talked about difference meaning subtraction. So we have r subtract 16. All of that is divided by 5. So I used a fraction bar to show that r subtract 16, that group is being divided by 5, and that is equal to 6. So we could include parentheses here around r minus 16, but because it's in a fraction bar and in the numerator, that would be a little bit redundant. So we don't necessarily need those parentheses. But it shows us that that group is in the numerator, and then we have 5 in the denominator. So if this is a group, then we need to undo what is happening to that group, right, to get to this variable. And that group is being divided by 5. So what's the opposite of dividing by 5? Go ahead and see if you can start solving this equation and resume the video when you're ready to check your work with mine. So I haven't completely finished solving mine, but I have it all set up. I use my line at the equal sign to divide the left expression from the right. We've talked about multiplying both sides by 5 to undo this dividing by 5. And since this is all being divided by 5, and if we multiply by 5, then what we're left with on the left is r minus 16. On the right, 6 times 5 is 30, so our equation has remained balanced as we start to undo it to find out what this value of r is by doing the same thing to both sides. And what is our final step? Well, you said add 16 to both sides. I would agree with you, so let's go ahead and do that. And if we do so, this subtract 16 with the added 16 is going to cancel out like a 0 pair. And on the left, we're going to be left with the value r, which is equal to, on the right, 30 plus 16 is 46. So the difference of r and 16 divided by 5 is equal to 6. When we solve that out, we find that that value of r is 46. Let's go ahead and try one last problem. Here's problem 3. Sally is making gift bags for 7 of her friends. She puts the same number of candies in each bag and 6 cookies. She started with a combined total of 98 items to put in the gift bags. How many candies did she put in each bag? So let's go ahead and first translate that into an equation and then start to solve it. If you'd like to pause the video here and try to work it out on your own, you're welcome to do so, and resume the video when you're ready to check back in. Alright, let's compare. So I wrote the equation as 7 times the quantity c plus 6 is 98. Because this grouping symbol with parentheses equals the number of candies that she put, said some number, so I just used c, plus the 6 cookies, right? That's each gift bag, times 7, because she's giving them to 7 friends. And we know that all of the items that she bought for this, the cookies and the candies, was a total of 98 items. So as I started to work to solve this equation, I remembered what we had done in that first example. And since this group is being multiplied by 7, I can undo that with, yep, you guessed it, dividing both sides by 7. So what do we get when we do that? Well, dividing this group by 7 cancels out the 7 that we were multiplying by, and 98 divided by 7 is 14. So we end up simplifying it, or starting to solve it down to c plus 6 equals 14. Now, to get c by itself and to undo this plus 6, I subtracted 6 from both sides, leaving me with an answer that c is equal to 8. So in the context of this story problem, my answer would be that Sally put 8 candies in each gift bag.